Hello everybody, this is Devi Prasad CN studying in second sem MBA of SVC, Sri Venkateswara College of Engineering, Bangalore. So I have got a topic about guidelines for formulation of linear programming model. So let us discuss about the guidelines for formulation of linear programming model. Linear programming is a mathematical approach used to optimize a specific objective such as minimizing cost or maximizing profits subject to a set of constraints. In this model, decision variable represent the quantities to be determined while constraints reflect the limitations and requirements of the problem. This linear programming model provides a structural method to efficiently allocate resources, solve complex problems, and support data-driven decisions. Linear programming is a mathematical method for optimizing a linear objective function subject to linear equality and inequality constraints. It is widely used in various fields such as economics, business, engineering, and military applications. Understanding how to formulate a linear programming model is crucial for effective problem solving and decision making also. Identifying the problem. It clearly defines the problem you are trying to solve to ensure the formulation is relevant and determine the objective of the problem, whether it's to maximize profit, minimize cost, or achieve a specific outcome, and also engage stakeholders to gather insights and validate the problem statement for accuracy and completeness. What are decision variables? Decision variables are the unknowns that you will solve for in your model. Identify and label each decision variable to represent quantities that can be controlled or adjusted. Ensure that the decision variables are relevant to the problem and can be quantified. Formulate the objective function. The objective function expresses the goal of the optimization problem in terms of decision variables. It should be a linear equation that combines the decision variables, reflecting the relationship between them and the objective. Double check that the objective function aligns with the defined goal and is mathematically sound. Establish the constraints. Constraints represent limitations or requirements that must be satisfied in the model. Identify all the relevant constraints, including resource limitations, budgetary restrictions, and capacity requirements. Ensure that each constraint is formulated as a linear equation or inequality involving the decision variable. Non-negativity restrictions. Most linear programming problems require that decision variable be non-negative. Clearly, they also clearly state any conditions that necessitate non-negativity, as negative values may not make sense in the context of the problem. This reinforces the realism of the model, ensuring that solutions are feasible in practical applications. Review and validate the model. After formulating the model, review each component to ensure that it accurately represents the problem. Validate the relationship in the objective function and constraints with stakeholders or subject matter experts. Adjust the formulations as necessary based on feedback to enhance the model's accuracy and effectiveness. Use of software tools. Utilize linear programming software tools such as Lindo, CPLX, or Excel solver for solving the formulated model. Familiarize yourself with the software's features to maximize efficiency in model solving and the analysis. Ensure that the input format matches the requirements of chosen software for seamless processing. Interpret the results. Analyze the output generated by linear programming solver to draw meaningful conclusions. Assess whether the solution meets the original objective and others to all the constraints. Communicate the results effectively to stakeholders, translating technical findings into actionable insights. Continuous improvement. Linear programming models can often be refined as new data or constraints emerge. Regularly revisit and update the model to reflect changes in the underlying problem or environment. Encourage a culture of continuous improvement to enhance decision making and optimize outcomes over the time. The linear programming model effectively addresses the optimization problem by identifying the optimal solution that meets all constraints. The model's results provide valuable insights for decision making, ensuring efficient resource allocation, and achieving the desired objectives. While the model has limitations due to assumptions, it remains a powerful tool for solving real world optimization problems and can be further refined to handle more complex scenarios. Thank you.